All right, so electricity. We've been talking about that for several videos now, and we're going to talk in this video about what can it accomplish. All right, so we talked about work way back when we were talking about classical physics and Newtonian mechanics and so on. Work was the idea that you could apply a force over a distance. In order to basically move something from one place to another, cause it to cause it to gain energy in most cases or whatever. Anyway, work involves expending energy in the way we talked about it before. And in this way, it actually still involves the idea of expending energy or using up energy. So the way that electricity does work is basically as follows. The source of your energy, the energy source, the power source for your electrical current, transfers the energy to the components of the circuit, and then the components transfer the energy to the environment. So in the case of this picture here, we've got lights, electric lights, lots of electric lights. So the electrical current goes into the light bulbs. The light bulbs then use that current to produce light, and then the light comes out and we can see it into the environment. So that's an example of a light. Here we have a heating element. This is a space heater. It also glows, so it's transferring light, but it's more importantly, it's transferring infrared radiation or heat into the surroundings. So again, the current goes into that heating element. The heating element emits the heat, and then it heats up the environment. And then here, obviously, that's a fan. And that fan, of course, would take the electrical energy in the motor and cause a circular motion of that fan blade, which would then move air, and then the energy goes into the environment as well. So those are three examples of how circuits can transfer energy from the power source to the components and then into the environment. So here I've got this idea set up as a sort of a circuit so that you can kind of see what's going on a little bit more directly, perhaps. This is a highly unrealistic circuit, but it's mainly to give you a visualization of what's going on. So you've got your source of electrical energy. In this case, it's a 9-volt battery. You've got the thing that's using the electrical energy, or the component, and that's in this case, it's just a fan, a computer fan. This kind of fan would be used for cooling off, like a processor in the computer. And then we've got a switch, and this is a knife switch, the totally impractical switch for most applications, but it's good for working in labs and so on. So in any case, when the switch is closed, the circuit is complete. Current flows around the circuit to the fan and then back to the power source. So you've got a complete circuit there, and the fan would use up the electrical energy that comes from the source in order to spin, and then transfers that energy to the surroundings as movement of air. Alright, so there are several different calculations we can perform using this concept and two equations. This equation, we've got power is equal to current times voltage, and that's a really important equation for a lot of things. The electrical power in terms of watts is going to be equal to the current in amps times the potential difference in volts. So P equals IV. Now, this equation is essentially the same thing as this one, but with a little bit of a different terminology. Because remember, power is equal to work over time. Let me do that off to the side here. Power is equal to work over time. And remember, work is a change in energy. So we could write that also as power is equal to the change in energy over time. Okay. Notice here in the equation we've got here, there's energy and there's time. You could rewrite this equation as energy over time is equal to current times voltage, and you've actually got the same, it's the same equation. So anyways, just went ahead and cleaned up all that mess so that we can see back to the main point. But yeah, essentially the point I was making was that these two equations are essentially the same thing. They're just rearranged with a couple of different terms. So here we have energy, electrical energy, and then this is time. So that's called work. When energy is transferred from one place to another, it's called work. So this equation might be used to show the amount of work that's done by the circuit, change in energy or work, and then this one gives you the power rating of whatever it is that you're using based on the current and the potential difference of that component. So there you go. That's the main idea of electrical work, and there's a lot of stuff you can do with these two equations and this concept. So we'll do some of that stuff in class, but for this video, I think this is long enough at this point, and that's the main idea. So thanks for watching, and I'll see you in the next video.